Hi, I'm Zubair, and if you've seen some of the previous episodes, you'll know that I've worked on NemCV, which is a system for making CVs in Denmark. The system is made in Clojure and ClojureScript, and the framework for building NemCV has been made with Clojure on Coils, which is a framework we've open sourced here. So one of the things that we've looked at is using Neo4j. So you can see that Neo4j is a graph database. I won't take you through the installation of Neo4j here, but just to show you that I do have it up and running on my local machine. So you can see some of the nodes here. So this is the Neo4j browser. So if you want to use Neo4j with Clojure, the most common Clojure library is Neocons, which is here, made by ClojureWorks. So on my website I've made a tutorial on Neocons for Neo4j, which is here. So I'll try and work through this tutorial and talk you through it as well. So if we start from the beginning of the tutorial, you can see that we have to install Neo4j first, and then you call Neo4j start to start the server, and it starts a web server on the local host as well, which is here, and this is what produces the Neo4j browser that I showed you earlier. Okay, now I have a Clojure project which is ready, which is in Lighttable. Lighttable is an IDE which is used for JavaScript and ClojureScript and other languages, and I think it's pretty amazing. So Lighttable is here, and it's now supported by a company called Cadoa, which is based in the States, and I have it already set up. I've showed in previous episodes how to set up Lighttable, so I won't go over it again here. So back to the tutorial now. So the first thing you'll need to do is to make sure that Neocons is included in your project CLJ in your Clojure project. So you have to include ClojureWorks and Neocons, and at the time I made the videos, 2.01 is the latest version which supports Neo4j 2.0 features as well. There's been quite a lot of changes in Neo4j, so it's well worth using the latest version. So if we look at the project.clj, you can see here we have the dependency on ClojureWorks Neocons 2.01. Okay, so as we've got here, so the first thing we should do is set up a Clojure file to do all this stuff. server, make a new file. We'll copy the stuff at the top of the file from another class, just so we can save on typing. Okay, so first thing we should do is connect to the local Neo4j database. Okay, so you can see here it's worked. Okay. Now, in the tutorial, however, it says it won't work, but that's because we need this require ClojureWorks Neocons rest, which is here. So we'd already done this, which is why this command worked the first time. Okay. So you can see here there's quite a few things in Neocons which we need to include. There's API docs for Neocons as well, which are well worth going through. So these are the Clojure namespaces. I've actually tried to make my own version of the Neocons API, which is still not complete, but it was more for my learning than anything else. Anyway, I'll go back to the tutorial now. So we need to require all these at the top of our Clojure file. Oops. Yeah. So if you look in the Clojure file, you can see they're kind of all here. Some stuff below as well. Okay, so it says here then if you do the connect it should work. And you can see here it does work. You have to do that with connection because otherwise you can't execute any other Neo4j commands, so that's very important. So going on, you can see here that we also show connecting to Neo4j, but we check to see if it actually does connect. Now the reason we do this is because if you have a system and it tries to connect and Neo4j doesn't exist or isn't running, then you don't want to have the system stop. So in Clojure on Coils it supports databases and Neo4j, so if you're not using Neo4j then it won't stop the system from starting up. Okay, so the next thing is nodes. Now nodes in Neo4j are these things here, so these contain data. I didn't need to do that, so these are all nodes. These are nodes and these lines between them are edges. They can both have data associated with them. Here you can see it has a property of a name Jack, and that's connected to another node which has an email of johnny@gmail.com, just an email I made up. And the property is the relationship between the two nodes are this line here, which is also known as an edge, and that has a type, which in this case is called hasLogin. You can see here on the left, relationship types. So here hasLogin. So here's all the nodes which have the hasLogin property connected to them. Relationship connected to them. Okay, so going back to the tutorial, I'll move these here so I don't get lost too much. Okay, so the most simple thing we can do is to create a node and send it to the output. So here you can see it created a node, and then it printed the node out, which you can't see because I need a console. These messages are something else, so you'll have to ignore them for now. But there you can see. I'll clear the console. Oh, okay. Apparently I can't. So, okay, so you can see here it's made an object of this type, or a closure record, and that was made by this. And NN is here. And you can see that also here in the tutorial. But it's a bit hard to read what it's saying, so I've expanded it a bit. Now, the most important thing to note is that it has an ID which is generated by Neo4j, and you should never store this because this can change between startups of Neo4j, so it's only used internally. We didn't put any data into the node, so it's empty. Next we can make a node with some data in it, which is here. Actually, what we can do before then is we can test that the node we made actually exists in Neo4j. So you can see the ID is 199. So if we go to the Neo4j data browser and we do start n equals node 199 turn n. So that's the Neo4j node we just made. Okay, so going on, we'll create a node with some data in it. So you can see here it's made a node with the number 200, and it's got all of this other data as well, which is shown here. Again, it's got an ID which is generated by Neo4j. The ID here and the ID here is different because Neo4j generates that itself, so it's going to be different every time. And here's the data that we specified here. Okay, so let's see. So the ID was 200. So if we now search, well, we want to see if that node has been made in Neo4j. So let's do 200. when you click on it, you can see here URL closure Neo4j.info, which is the ClojureWorks URL for Neocons, and the domain is ClojureNeo4j.info, which is exactly what we specified here. You can see in my example I've got too many brackets actually. I'll have to fix that at some point. Okay, so going on, so we can make a node now. Going on, oh, by the way, the commands I was typing up here are the Neo4j language, which is called Cypher. You can learn more about Cypher at the Neo4j Cypher website. There's quite a few interesting things. There's this Neo4j Cypher ref card, which shows you all the commands, which is a PDF, I think. And then there's the Cypher site on the Neo4j website itself, which is quite good because it lets you run Cypher commands interactively. So I can even change it here. You can see the output here. There's one record here. Okay, so back to the tutorial. Okay, so the next thing is, oh yeah, there's one point here. You'll see sometimes these URLs in the data returned by Neocons, and these are URLs which you can use to ask Neo4j for different node or relationship data. So you can see, for example, if you get a node back, you can, not here, but maybe here, if you get a node back, you can query it with Neocons like this. So we can test that. In this case, you can see there's no node, but if we put in 200, you can see it returns a record, closure record, the same as before. Okay, so let's go back to the tutorial again. The next thing to know is how to make relationships in Neo4j. So you can see from earlier in our Neo4j browser, these are relationships, so they link one node to another node. This one's called has login, so saying a user called Jack has a login of Jack at Hotmail. Okay, so to make a relationship, we have to do something like this, where you make one node, you make a second node, and then you link the two. You can see here that even though it's a create method, it's got a different namespace. It's definitely worth making yourself familiar with the ClojureWorks Neocons API, which is here. You can see here is the API for nodes. You have create and all, and there's a lot of stuff here. And then for records and relationships, there's a lot there. And for spatial, if you want to make mapping applications. So let's go back here. So we have two nodes here, and then we make a link between them. So we put that into, if we enter that into light table, you can see here we have a relationship. And if we go back to the tutorial, you can see it returns something like this, which when it's broken out is like this. So again, it's a closure record of type relationship. We can go to the Neo4j data browser and search for it as well. The ID is 76. So let's go here. Okay. One thing is I searched for a node. Should search for a relationship here. So a bit of cipher here. So here's the node with ID 76. You can see here, and it's linking nodes 202, which is this, and this ClojureWorks and Clojure Neo for info. So if you go here, you'll see that's what we had here. So it's linking these two nodes. So you can see that did actually work. Again, I've got too many brackets. I'll have to get rid of that sometime in the tutorial. Okay, so the next thing is, if we look at what we get back, we get the Neo4j ID of the relationship type. Here it says links. So it's saying, you can see the text there. It says, it's not actually. It's interesting to note that the type is not actually a property. A node can have properties, but they're optional. But they have to have a type, I think. I'll have to check that actually. So if we go back to the tutorial here, we can see also that has a start node and an end node. So this is the URL of these are the URLs of this and this. Okay. There's also other stuff we can do with Neocons. I won't go further with the relationships, but you can check to see which you can check to see what a node links to. So here we're saying we have a user called Amy, a user called Bob. We make them both friends of each other and classmates, and then we say, tell us who's a friend or a classmate of Amy. So we can do that like this. And what we get back this time is a bit more complicated, because we get back two records, because it's a closure list. So we get one relationship here where it's saying Amy has a friend from college. Here's source college, a friend from college, friend from college, and Amy also has a classmate from maths. So that's here, a classmate from maths. Okay. Let's see what's in there. We can check that in the Neo4j data browser. So if we go here and we see okay, so Amy must be node 203. So if we go here, we search for Amy. Now it doesn't show any relationships, so I've done something wrong. Let me have a look. Let's search in a relationship. This is a relationship, and it says Amy here is a classmate of Bob. So I'm not sure why it's not showing the relationship here. That's something that will have to be, I'll have to look into later, and maybe it's a good exercise for you. At this point I should probably stop the tutorial because it looks like my knowledge is a bit limited. Although this may be, okay, that can be an exercise to find why the browser didn't show that. The next thing is, it's very important that you can use the Neo4j cipher language, which is this thing I've been entering up here. This is the cipher language, which I'm not expert at yet, as you can see. So when you want to execute a cipher query, you can do it like this. So you can use there's two ways: is query and tquery, but tquery puts the results from a cipher query in like a tabular form. So I'd always recommend using tquery actually. So here we have a cipher command, which is this, and then we can try it out in light table there, so you can see it's printed out. It still looks quite complex like this, but you can see here, how it came out. But so what it does is it comes out with a list of maps which have in cipher, whatever you put into the return statement comes back as a field in the map. If you, however, just print, in this case it prints out a whole node, which is why it's quite complex. But if you just return individual fields, then it returns just numbers. So if we do this, it should return something like this here. So let's have a look. So if we do this, I'm not sure what happened here. Oh, okay. Oh, sorry, I did the wrong one. So here you can see it's returned username and age, and it's kind of readable. And that's because that's what was in the return statement here. So tquery is definitely the one I'd recommend using. And I've got I go into a bit more depth online in the example. and I even cover query as well. Anyway, there's some other stuff. There's some new stuff in Neo4j 2 called labels, which is like adding types, or you can bunch nodes into a table-like structure for people who are more used to databases, and that's very useful. And I think that's about it actually for this session. So thanks for watching, and don't forget to you can see my blog here, and you should also remember to go to Neocons if you want to get access to the Clojure Neo4j API, and that's made by ClojureWorks, who also have a lot of other stuff actually. They're very good. ClojureWorks. They've got a lot of stuff. You can see, I mean, this is just one of them. So they're definitely worth checking out. Check out Neo4j itself, Light Table, Cadoa, Learn Cipher, and try the examples online, and you'll be good to go. Okay, thanks for watching. Bye.